and that one will give us area of surface area rather of a cube. Surface area of a cube. Surface area of a cube. Let's see. So here we have the lengths are 12. All the lengths are 12 of that cube. The lengths are 12. It will be 12 times 12. The answer we have, we multiply by 6, giving us here, it will give us here 864 square centimeters. 864 square centimeters. This is very interesting with the cube. Area of one face, multiply by 6. You are done. You have your surface area. As we said, all the faces are equal and the same. Let's come to another example. Find the surface area of a closed cuboid. And keywords, underline the keywords, closed cuboid, shown in the figure below. The cuboid is closed. What is its surface area? The first thing that should run into your mind, what is the formula of a closed cuboid? 1, we'll get the surface area of the 6 rectangles. Remember, a cuboid is made up of 6 faces. All these 6 faces of a cuboid are rectangular in shape. So we get the area of all the 6 rectangles according to the formulas we have. We go. Area of 2 faces measuring 8 by 6. Area of 2 faces measuring 8 by 6. You say 2 into 8 times 6, which will give us here 96. That is area of one face gone. Area of 2 faces measuring 6 by 10. Area of 2 faces measuring 6 by 10, which will be not 6 by 10, rather 8 by 10. So there are 2. We say 2 into 8 times 10, and this one will give us 130 square units, square centimeters, I mean. And we come to the third area of 2 faces measuring 10 centimeters by 6 centimeters. There are 2 faces, so we say 2 into 10 times 6. This one will give us here 120 square centimeters. Just to come back, this one is according to the formulas. This one is according to the formulas that we have of our cuboid. The formulas we have of our cuboid. Let's look at the cuboid first of all. This is the cuboid. This the face that this is the one that is measuring length, the measurement for length, and this one for width, which is 6, and this one is for height, which is also given here as 8. So we multiply area, as we say, 2 into length times width plus 2 into length times width for the side that is facing us plus 2 into width times height. And that one is clearly indicated here when we talk of area of 2 faces measuring this by this. And now we come to get the total surface area. We'll add all the area of the 6 faces. The first 2 faces gave us 96. The second 2 faces gave us 160. The third 2 faces gave us 120. So when we put the 6 faces together, we'll arrive at 376 as our surface area, That's about a closed cuboid. You know, when it is open, you know which face is not there. When it is open, you know which face is not there. Example number 3 is this one. This is a cylinder. What is the area of the curved surface area? What is the area of the curved surface of the cylinder below? I said underline the key words. Underline the key words. Somebody will just rush without underlining the key words and then work out the surface area of the cylinder. But look at the question. Very key. What is the area of the curved surface of the cylinder? Curved surface, not what is the area of this, what is the surface area of the cylinder. So be keen. Identify the key part of the question, and this key part of the question will simply lead us where we will get our solution. So area of curved, I said curved part is this part that we are seeing here. This part, this is what I said is curved. Yes, if that is our curved part. And I said when you're working out curved part, you multiply circumference times height. You multiply circumference times height. And what is the formula of getting circumference? Circumference we say equals to pi d. Circumference is equals to pi d. Therefore, this one will simply give us pi d h. We are multiplying by h. Pi d h. And check on your shape always. Don't get confused. If the shape can be in this form, it can be drawn like this, slanting along the ground. This one will still be our h, and now we'll call it length. And this one will still be our circular part, which will say circumference equals to pi d. And now instead of h, you say pi d l. Instead of h, you can say pi d l. And whether you use pi d h in this case, but remember what is h. You should know what is h. The same shape can be drawn. You can be told, not drawn, you can be told that a swimming pool was dug under the ground. The swimming pool was dug. After the swimming pool, then this one will be given. Remember this now, the ground, our ground will be somewhere here. So you go down. So this one going down, we call it breadth. We call it breadth. And when you will be asked its surface area of the curved part, remember the formula. So we say the formula of working out area of the curved surface of the curved part, we say circumference times height, as I have indicated here, circumference times height. Circumference itself is pi d. Circumference itself is pi d. Or instead of saying pi d for circumference, you can also say 2 pi r. Circumference can be pi d or 2 pi r. So this one will make a simple change in this formula and will say is equals to 2 pi r h. 2 pi r h. As we have used here, we said 2 pi r h. 2 pi r h, because circumference is given by two formulas. The first formula of getting circumference, you can say pi d h, or whereby d is diameter, And the second formula you can say 2 pi r. 2 pi r. 2 will stand for the two radius that will make up the diameter. So we'll have 2 times 22/7 times our our radius, our diameter here, which is 1.4 times 10, and when we multiply these ones, they will give us 800, and they will give us here 880. They will give us 880, and that is circumference of the curved part. That is circumference of the curved part. At the same time, we can be given circumference to work out the surface area of a closed cylinder, as I elaborated earlier, whereby we say 2 pi r squared. But what about in a case we are given this one here? What about in a case we are given a cylinder? We have a cylinder, and then we've been told that this cylinder is open on the top. It is open. This is not there. This is not there. The formula we use will say we'll have area of bottom, this bottom part. We'll have the area of the bottom part. We'll have the area of the bottom part. Area of the bottom part, which is a circular shape, which will give us pi r, will give us pi r squared, and plus area of the curved part, which will be pi dh. So this is only if the cylinder is opened at the top. If the cylinder is opened at the top, and the cylinder can only be open on one part. The cylinder will only be open on one part, and that is the top. The cylinder will only be open on one part, and that is the top. So we'll exclude surface area of one part, that is the one top, and then we work out the surface area of the other part. Okay. Now we have some questions with me, and let me just get the questions so that I can go some questions from my students, my pupils. And question number 1. Let's get question number 1. We have question number 1. Okay. Question number 1. Leon asked, how many vertices, edges, and faces does a cylinder have? How many vertices, faces, and edges does a cylinder have? Leon will have this diagram here. This is our diagram. This is our diagram. And this is a diagram of a cylinder. This is a diagram of a cylinder. This is a diagram of a cylinder. This is the diagram of the cylinder. Now, how many faces do we have? In this cylinder, we'll talk of 3 faces. If it is closed, we have top, we have bottom, and then we have the curved part. This is a face on its own. Remember, when we open the cylinder, we'll have that one, we'll have this one. We are opening the cylinder, and these are the faces we'll have on our cylinder. The cylinder will have these 3 faces. This is how we open the cylinder. This is what is made up of the cylinder, because this rectangular shape, this one here, will make our curved part. This one will make our top. This one will make our bottom. So top, curved, bottom. So the faces are 3. We have 3 faces. Let's come to the vertices. Let's come to the vertices. First of all, what is a vertex? What is a vertex? A vertex is whereby 2 or more faces meet. Where 2 or more faces meet. Look at the vertices is that a vertex is that point. We have the point where we have the joining of particular lines. For example, let me just have an example. This one like this, like this. So this point here, where 2 or more lines meet, that we call it a vertex. So when there are many, we call them vertices. So let's look at our cylinder. This is the cylinder. If you look at the cylinder clearly, we can't get the vertex. Let's look up there. We don't have that vertex. We don't have a vertex in a cylinder. And what about the edges? The edges. An edge. An edge, for example, is where 2 or more faces meet. That is what we call an edge. So one face meets another. So in our cylinder, we have 3 faces, and these 3 faces meet at different points. This face here, this face, it meets this face along this line. And this face here, this downer face, it meets the curved part along that line. So in that case, we can have the 3 edges. We can talk about 2 edges. We cannot talk about 3. We talk of 2 edges because the same face, this one meeting the top, the same face meeting the bottom. So those are the edges. There are only 2 along the edge of a cylinder. There are only 2. So we'll have 3 faces, 2 edges, and here we have nothing. Okay. We have Yvonne from Zero. Yvonne from Zero is asking how we can get. Yvonne from Zero is asking how we can calculate surface area of an open cube. Surface area of an open cube. Thank you, Yvonne, for that question. And this is how we work out surface area of an open cube. Let's have an example of a cube here. Our cube here, that's a sketch drawn of a cube. So this is our cube here, Yvonne. So Yvonne, this part is open. This part is open. This one is open. It is not there. Remember I said when it is closed, we say length times length. This one you multiply by 6. But now one face is missing. What do we do? It will be length times length. One face is not there. Multiply by 5. Length times length, multiply by 5. Because one face is missing. When it is closed, length times length times 6. When it is not there, one face is missing. Length times length times 5. One face is missing. Fiona is asking for area of an open cylinder and the area of a closed cylinder. I think we tackled them earlier, but I will just give you how we go about area of an open cylinder. This is our cylinder. So this is the cylinder. This part is open, and I said a cylinder can only be open on one side. So how do you get the formula of open cylinder? So surface area of open cylinder is equals to surface area will be equal to area of bottom. This is our bottom, this is our bottom, this is our bottom. Area of bottom, which is a circle, so we say pi r squared plus area of curved part, this curved part, which is pi d h. Area of the bottom, pi r squared, plus area of the top of the curved part, pi d h. For example, let's say here you've been given as the radius as 7. The radius is 7, and then the height here is 10. So we'll say this one equals to 22 over 7 times radius 7 times 7. This one is for the bottom plus pi dh, that is for the curved, 22 over 7 times diameter. If radius is 7, diameter is 14 times 14 times height 10. Sawa. So we simplify by cancellation. Here 1, here 1. So 7 times 22 is 154. Plus, for this one, 7 here 1, 7 here 2. 2. 22 times 2 is 44. 44 times 10 is 440. So we put these two together. Here 44. So here 4, 9, 5, 96. That is when it is open. That is when it is open. Okay. Question number 3 is coming from Abigail. What is the area of borders? What is the area of borders? Oh, thank you, Abigail, for that question. And area of borders, we don't deal with area of borders in surface area. We have a subtopic on its own, area of borders. And just to answer you, area of borders will depend. Area of borders will depend with which border are we talking about, which shape do we have that we are asking its border, because we can have a circle, we can have a square, we can have a rectangle, or in that case, let me just give you one example so that you can be clear on that, Abigail. So, for example, we have this one. Oh, sorry for this one. Then they have here. Maybe this part is shaded. This part is shaded. This part is shaded. So that shaded part is what we call a border. So we'll talk area of border in differently as areas of surface area. Surface area, as I said when we started, is the area of all the faces that we have. Then we put them together. Area of all the faces that we have, then we put them together. Thereby, we are talking area, surface, total surface area. Area of borders I've mentioned, we have different shapes. We'll be asked to work out different area of the borders. So we'll see about it in our next lesson. Esther is having questions here. Question number 1. A closed cylinder is measuring a closed cylindrical tin measuring 14 centimeters in radius and 30 centimeters height was painted white on the outer part, excluding the top and the bottom parts. What is the surface area painted? Good, Esther. A good question for that matter, Esther. Let me just use very fast, Esther. When we talk of a closed cylinder, it was painted white on the curved part only. It was painted white on the curved part only. What does the question ask? The question simply asks for what is the surface area of the curved part. And bringing this one to our attention, remember, we can also be told it was wrapped using a piece of paper. So what surface area was covered by the piece of paper? So let's have for the Esther's case, this one here is our closed cylinders of radius measuring radius, radius here, not diameter. The radius measuring 14 centimeters, and the height is 30 centimeters. So in this case, the question simply asks for the area that was painted white, excluding means do not include the top and the bottom. It's only the curved part that was painted. Top and bottom, leave them. This is how we go about the question. Okay, the first thing, as I will insist, always put your formula down. Surface area is equals to, it's only area of curved part. Surface area of curved is equals to pi d h. Surface area of curved part, pi d h. I explained that it is circumference. Earlier I said it is circumference times height. Circumference times height. Therefore, we'll simply say pi d, because formula of getting area of circumference is pi d. We mentioned that one earlier, the circumference is given by pi d. So here we'll say circumference times height. Circumference times height. Therefore, this circumference is replaced by pi d. So we say pi d h. So this one will be equal to 22/7 times radius is 14. Our diameter will be 28. Our diameter will be 28. So this 28 we multiply by height, which is 30. This 28 multiplied by height, which is 30. So we'll say area is equals to surface area of the curved part is equals to circumference times height, whereby the circumference is pi d. Circumference is pi d, which we have 22/7 times diameter, which will be 28 because the radius is 14, times height, which is 30. So when we simplify by cancellation, we'll say 7 here, 1, 7 here, 4. So we'll have 22 times 4 times 30. 22 times 4 times 30, and this one will give us 22,640 square centimeters. 2,640 square centimeters. I will go over the question again so that we understand better. The question, this one was painted white, and that one simply, it is the curved part. This curved part was painted white, this one. So we say surface area of curved part is equals to circumference times height. Circumference is given as pi d. Circumference is given as pi d. Circumference is simply this distance going around this shape on top. So it will be pi d h, 22/7 times 28 times 30, and that one will give us, we use simplification by cancellation, we get 7 into 28, 4. Then that one will lead us to multiplication, we get 2,640. 6,240. How Question that follows: how will you work a question in an open cuboid? Very good. How will you work a question in an open cuboid? We simply gave out the formula, but we did not work it out. Let's see. Let us get one here. Okay, so we have here one question, number 3 in this case. Number 3 in that case, we have that one. An open rectangular tank has a base measuring 2.0 meters by 1.5 meters. It has a height of 2.5 meters. The surface area of the tank was painted. What was the total area painted? This is the same as the question that we've been asked. How can we work out area of an open cuboid? So we'll start by having our formula down. Remember, first of all, let us have the cuboid. It is a rectangular cuboid. Let's have the rectangular cuboid here. Let's have a rectangular cuboid here. That's our rectangular cuboid. It was open. The base measuring 2 meters. 2.0 is the same as 2 meters. 2 meters by 1.5 meters. So here is 1.5. That is the base. And what about the height? The height is 2.5. 2.5. Okay. What is the formula? What is the formula? We come to our formula and we say formula of open surface area of open cuboid is equals to length times width. Remember, it is open. Length times width plus 2 in sorry, this bracket should not be here. This bracket should not be there. Plus 2 into length times width. I say you can call it width or you can call it height. Then plus 2 into width times height. 2 into width times height. So you come to our measurements. We come to our measurements here. So the base is, since the top is not there, this part here is open. This is open. We come to this one here, this bottom part. So we'll have the bottom part down there. So this is what we are going to work out. The length is 2, the width is 1.5. So we'll say length times width, which will give us this equals to 2 times 1.5 plus we come to 2 into, let's get our unit here, 2 into length times width, another length times width. That is now for this face here, this face facing us there. It is 2 by height. The height is 2.5. So it will be 2 into 2 times 2.5, close the bracket, plus the third part, width times height. So our width is 1.5 plus we have 2 into width times height, 2 here, plus, not plus here, that's a mistake here, 1.5 times our height is 2.5. That's all about those shapes. We simply multiply. When you multiply this one, you will get 3 plus we multiply this 2 times 2.5, you get 5. 5 times 2 is 10 plus this one here, we multiply this one. So you when you multiply decimal numbers with decimal points, assume the decimal. After assuming the decimal point, multiply as if you are multiplying whole numbers, then finally insert the decimal point. So in short, I'm saying you multiply 15 times 25. 15 times 25 is 375. How many decimal places? 1, 2. You insert from the right. 1, 2. So here, so we'll have 3.75. When we add these ones, we'll get 3 plus 10 is 13. Then 13 plus 3.75 will be 16.75 square centimeters. So far, those are the questions, and to just conclude, I will urge you on one thing. Okay. On conclusion, I'll just tell you, always follow the formula. Check on your accuracy. That is where I was talking about which part is open, what is the measurement, what is the length. Be very accurate, check on time. Formulas must be followed so that you arrive at the correct answer. Thank you so much, my pupils, for listening. Have a nice day altogether.